Welcome to In 5 Minutes. In this video clip, we will start with the introduction to multi-rate signal processing. We will try to answer two very important questions. Number one, what is multi-rate DSP? And second, what are the applications of multi-rate DSP? To understand what is multi-rate DSP, we will first consider a continuous time signal x of t and discuss the conversion of x of t to a discrete time signal x of n. I'm sure everyone knows that to convert a continuous time signal x of t to a discrete time signal x of n, the process that we require is called sampling. So when you sample the continuous time signal x of t, you convert it to discrete time signal. In the process of sampling, we simply replace the continuous time variable t with an expression nts, where n will be nothing but an integer. It will take integer values, and ts is the sampling time period. By doing this, we convert x of t to x of nts. So all we have to do is we simply read the values of x of t at discrete time instance. For example, if I put n equal to 0, the first sample we take at t equal to 0. If I put n equal to 1, the next sample we take at t equal to ts. If I put n equal to 2, we take the next sample at t equal to 2ts, and so on. So we consider some specific time instance given by nts and only keep those values from x of t. So this will further give me x of n. So whenever we have to convert a continuous time signal to discrete time signal, there is always some sampling time period involved. In other words, I can further write this thing as n by fs, because 1 by ts is nothing but fs, or ts will be 1 by fs. Fs will be the sampling frequency. It is called sampling frequency or sampling rate. Fs is nothing but the value which will correspond to the number of samples that we have taken per second. So for example, if fs is equal to, let's say, 1000 hertz, this means we are taking 1000 samples per second. So in simple words, fs can also be called as sampling rate. It is the rate at which the sampling is done to continuous time signal x of t. I repeat, if fs is equal to 1 kilohertz or 1000 hertz, that means every 1 second I'll be reading 1000 values from x of t, and hence my ts has to be set accordingly. Ts will be 1 upon 1000, that will be 1 millisecond. So after every 1 millisecond we will read one sample from x of t. So by the time 1 second is passed, I'll be able to read 1000 samples. So that means whenever I give you a discrete time signal x of n, it will always have some value associated with it, which is called sampling rate or sampling frequency in simple words. So let us consider a signal x of n with fx as the sampling rate. Fx will be nothing but the value of the sampling frequency fs at which x of t was sampled to obtain x of n. So we have considered x of n with sampling rate fx. Now in many applications we require that x of n be available at some different sampling rate. So now what is the requirement? The requirement is that we want to have x of n with sampling rate of, let's say, fy. So fy is the sampling rate that we want to be associated with x of n. Now what does that mean in simple words? Suppose if I give you x of t and if you convert it to x of n using the sampling frequency value of, let's say, 1000 hertz, but now suddenly you want the same x of n available at a new sampling rate, which is, let's say, fy equal to 500 hertz. So in that case, what you should do, when I say I want x of n with 500 hertz of sampling rate, that means I want to keep only 500 samples per second, but in the original x of n I have got 1000 samples per second. So that's first problem that we are talking about. Or it may also happen that in another application I want same x of n, this time with sampling rate of 2000 hertz. So that means original x of n has 1000 samples per second, but I want to increase it to 2000 samples per second. So let us now see how this can be done, how I can have the same x of n with reduced number of samples per second or increased number of sample per second. To do this, there are two approaches available. Let us discuss approach number one first.